This video will walk through my going through the lab for week 2, and in places I will actually capture me building the code and interface in the model, so you can actually watch the key clicks in case that's helpful. First, we'll review kind of what we worked on in Lab 1, which focused kind of on the functions of sliders, buttons, monitors, and the various tabs and other aspects of the display, including perhaps the animation. And then we'll actually take an existing model and take a close look at a couple of these features, delete them, and then re-add them to begin to get the feel for how you create components within a NetLogo model. So the first thing we're going to do is open up the file we worked with last week, which was the Traffic Basic, which is in Models Library, Social Science, Traffic Basic. So click on that. I'm going down below what you can see. It says I'm just pushing the open button a little bit below on that window. So first thing we wanted to do is just re-familiarize ourselves with the various parts of this. First, there's the interface, which contains the sliders, buttons, displays, or monitors they're called, graphs optionally, as well as an animation, which you see right here, which is empty right now because we haven't pushed the setup. The next part is the Info tab, which I'll just scroll very quickly through there. You can just see that there's a lot of useful information about this model, and any of these models, they typically try to release them with a certain amount of useful tips about what the model does and how to use it. And then, of course, we spent a little bit of time reading through the code, which here you can see is about a full page maybe of code associated with it, with some documentation. Also, when we go back to the Interface tab, you'll notice there's a command center over here. We'll be getting to that later in the lab, but the observer can type commands and make things happen, which you can see in the animation and potentially see up above. And we'll eventually start using that more. Now we just want to be aware of where it is. Okay, so the first thing we want to do then is on the Interface tab is open up one of the tools, which in this case is a slider. It's the number of cars. I'm going to start to the upper left-hand corner and then let go, and it'll highlight it. Then if I double click, it brings that open, and you can see this one describes the number of cars, and because it's a slider, you need to know what range it can run over. So it can go from 1 to 41 in increments of 1, and the current value that it starts up with is 20. There's an option to make it vertical. So if I just say OK, it'll put that one back. Similarly, if we highlight Setup and open it, we can see that all that does is run the command setup. So we should be able to find something called setup over in the code. We'll do that right now just to kind of verify and make that connection. So if we go over to the code, notice that it says to setup. That's the word that button points to. It executes this procedure highlighted from here to here. So going back to the interface, the Go button is similar. Let's take a look at this reporter here. I'm just going to open that up, double click, and you can see it runs a little bit of logic. It says if else any turtles, speed of sample car. So it's checking to see if there is any turtles, and if there is, and there's a sample car, then it returns the speed of the sample car. Otherwise, it returns 0 if there is no sample car. Here's the name of it, and you can see there's some information about accuracy and fonts. Finally, the graph, just to show you the graph, if we highlight that, you'll notice that It has, you can be doing this on any number of things. It has legends and labels, but most importantly, it says for various colors on the graph, what are they called? There's the name that you enter, and then what logic is needed to estimate that. So it says plot the speed, which is a variable that each car has, and the sample car in particular is the one that we're watching. And then the minimum speed is plot the minimum, so it actually takes the minimum value of the speed of all the turtles. So as soon as we say of turtles, that means look at the speed values of all the turtles and plot the smallest, and then plot the maximum value of all the turtles as well. So that's just a quick review of some of the things that you have available to you. All right, so now we're going to just practice entering our own rather than just looking at them. So the first thing I'm going to do is I'm going to delete the slider for number of cars and then put it back again. So first open it up real quick and remember what we have. Oh, by the way, before we do that, actually what we ought to do, we never did this before, is actually run the model. So let me run setup. It sets up our little screen down here, and then go, and we can watch the cars go. And we can see the graphs produced. Now I'm going to stop. Now I'm going to take that number of cars, take a look at it, make sure I know what's in there. 1 by 1 to 41, starting at 20. So now I can highlight it again and push the delete button. Actually hit the delete key. And now all of a sudden it takes us over and says, oops, nothing named number of cars has been defined. Now, notice that it's highlighted. This is really useful. It's highlighted number of cars. It guesses I'm going to want to go and make that slider. So if I've put in some code and I haven't created the sliders yet, there'll be these errors. I can simply hit Control-C, and now I have number of cars in the buffer. I can go back to Interface. I can go select what I want. I want a slider. So first I select slider and say add, come down and left click, double click, actually I'm right clicking now and typing slider, and then I can go Control V to paste number of cars. Minimum is to be 1, increment of 1. This is to be 41. Everything else, this is to start at 20. And then I can say OK. Now let's run setup and go. Looks pretty similar to what we had before. All right, so let's delete one of the other buttons. Let's delete or one of the other objects. How about setup? Setup, as you remember, just says setup. So we should be able to cancel that, highlight it, push delete, then go to add and right click button and setup. I can just type this one. It's a really easy one. And now I should be able to push setup. It sets it up and go. We're back and running again. So let's just do one more. The whole point here is just to experiment with simply looking at what someone else has created and learning how to emulate what they did. So we won't try to do a graph or anything fancy like that. The other sliders work the same as number of cars, although they have different parameters on them. Finally, let's look at red car speed. So, oops, I just made a little mistake. I can hit cancel and it will take that out. I'm still selecting. I had the add going to add something, so it did that. Instead of letting me click and highlight red speed, open that up. Here, you'll see we've got some code to write. If else dash value any turtles. I'm going to have a hard time remembering that and doing it, so I'm going to cheat just a little bit. You probably will too. I'm going to copy that code, Control C, although my advice is always if you don't copy it but type it in, it actually helps your fingers learn the syntax of the language. Decimal places is 3, font size is 11, and it's called red car speed. I can remember that. So, okay, I'm going to go ahead and highlight and delete that. And now I want to add, right-click a monitor, and the reporter I'm going to Control V paste. I should type that in. Red car speed, font size 11. I don't need all those decimal. By default it was 17. We're just going to go 3 decimal places. And I can say OK. It came back. It's clearly working. We can run setup and go and see that that value is continuing to work. So really that's the point of this part of the lab, was just to experiment very, very safely with entering features on a model. The other thing we'll do in this part of the lab is just kind of work through some of the common commands. And we sort of suggest that you either print it out. These pages are updated from what I had earlier because we have a new version. And the other option is just to get the dictionary open as described here, so that you can search it electronically. That can be handy. Some people prefer one or the other. What I want you to do is just on the list that we're going to look at next, which I'll just talk through in animation mode. I mean, I won't animate it, but I'll just talk through the list. What do these commands do? Try to just explain to yourself what you think they do, and if you have a partner, it's great to compare notes on this sort of thing. All right, so CRT, or Create Turtle, has a bunch of operands after it. You can look it up in the guide, but it creates turtles, a certain number of turtles. And usually that's often specified on a slider when you build a model. Set color sets the color of the turtles or a patch, depending on which way you use it. Set XY sets the XY coordinates, the position. So if you created a turtle and you wanted to set its color, in the square braces that follow the CRT command, you'd say set color, red, set XY, and you'd specify 2 operands, which would be the X and Y coordinates. Then LT is left turn, RT is right turn, FD is forward, BK is back. So that tells the turtles to move, and the operation is how far do you want it to move. And also, when you tell it to turn, you're changing the heading. And when you tell it to go forward, you're moving it in the direction of its heading. A very powerful general command is ask patches. You'll see that used a lot. And then in the brackets after that, which can often be several lines of code, you'll be telling patches, all patches in this case, to do something unless you modify the command to ask only a subset of patches. Ask turtles is the same thing, but it asks all of the turtles in the model. But again, you can ask turtles with certain characteristics to execute commands, like change their color or move or do other things. CA is clear all. That's used at the beginning of setups, usually just to kind of make sure that you've got a blank window to paint for the animation part. If you only want to clear the turtles but leave the patches as they are, you can use CT. And set heading, position is set by set XY. Heading is the direction that you're going. So you could be moving at a particular angle through the patches, and that command is used to set the heading of a given turtle or of a set of turtles or whatever. Often set with random numbers in actual models. Random allows you to ask NetLogo to give you a number. So you say random 100 will give you a random number between 0 and 100, things like that. So you can look up the exact syntax. Die, just if you issue a command, if you say ask turtles die, all the turtles will die. So that's the process. You can stop says to stop running, but don't clear any of the displays or anything. It just tells the simulation to stop. Print is a command that's used usually more in debugging, but you could also use it to create output. But it's as your model is running, you might want to create a log of things that are happening. So there's both print and type. And type, I believe, does not include a carriage return. So it just keeps, if you say type, 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 it'll just keep putting them in one row. Whereas you say print, it inserts a line feed after every print statement. I think I have that correct, but the documentation will tell you. If is, of course, a command. If you embed the word if in logic, it's going to expect the next thing to be a test. And then what you tell it what to do if the test is true. And if you had if else, then the else condition could be applied. Otherwise, it'll just move on. If it doesn't pass the if test, it just goes on to the next line of code. Scale color is if you want to have the color of something be different shades of that color, like green. You could have it be from very light green to very dark green. So you'd want to look at the syntax on this, but it lets you color things. It's commonly used. You'll see lots of examples of it. Color things based on the value of a variable between some amount and some other amount. That's going to make it green, either very dark green or very light green. Same thing with patch color. You can do the same. Setting the patch color just sets patch color to a color. CCT stands for Create Custom Turtle, which means that you can specify more attributes than you can with just a create turtle. So custom lets you specify what it looks like and things like that. And then finally on this list, jump basically is a way of telling an agent to move to a specific coordinates from where it is, kind of like a teleporter. All right, for part B of the lab, we're going to actually go create a fairly straightforward model, an interesting model. And first we'll enter the code and talk a little bit about the code, what it means. I'm not going to kind of describe every single thing in the code. That would be probably too much. And notice that there will be undefined variables, those messages will go away once we create the interface. I recommend that you just type it in, and you'll learn as you type. In order to make this lab not inordinately long, I am going to copy and paste it and then just read some of the lines and illustrate the idea of how I recommend doing the lab. Ideally with a partner, or you can just kind of think to yourself or talk to yourself about what do you think the lines do. Of course, you'll probably need to consult the manual to unpack some of the commands. All right, so this is the code. And I'll read a few lines just to give you an idea. You should be thinking about what do these things mean. So patches own means that each patch has a variable associated with itself called chemical, or the value of the amount of chemical that it has on or associated with that patch. So here we've got some procedures. One is the setup procedure where we clear all. We talked about that a minute ago. We'll create turtles. How many? The population, whatever the population slider says. For each one of those turtles, we're going to set the color to red and set its XY coordinates to a random X coordinate and a random Y coordinate. Then we're going to ask the patches to set their amount of chemical to 0. So that's it for the setup process. Then to go, we ask the turtles if there's chemical above some minimum threshold called sniff threshold, which is a slider, turn towards that chemical. That procedure is down below. Then do a right turn, a random amount floating based on the wiggle angle, which is another slider, minus another random amount adjusted by the wiggle angle, plus the wiggle bias, which tends to make it move more to the right or to the left. Then move forward, then set the amount of chemical equal to the chemical plus 2. So add 2 to the amount of chemical, and then diffuse the chemical and ask the patches to set their chemical to a little bit less. That's like evaporation or going away. And then set the patch color to be the scale according to color green between 2 values. Finally, the utility, I guess I might as well finish this. The last part of it says to turn towards the chemical. It uses some local variables. So let makes a local variable called ahead, a local variable called my right, my left. And what it does is it tries to figure out what direction would be the best way to turn. So then it asks a condition. If else, my right is greater than ahead and my right is greater than left, then right turn, sniff angle, etc. I'm not going to unpack that perfectly, but you can see the point here is it's trying to make a decision to get it set so that its heading is pointed towards the chemical, the best place to go in its neighborhood. All right, so we are now capturing the building of a model from scratch. So I just opened up NetLogo. I'm going to go File, Save As to give it a name. I'm going to put it on the desktop for me for right now, and it's just going to be called Lab 2 Model. And I'm going to go to the Code tab, and the first thing we wanted to put in was patches own bracket chemical and then to setup. It indents automatically. Clear all. Create turtles, population, the amount, and then we're going to indent a little bit and put a left square brace and put in set color red, and then we're going to go to the next line and we're going to set XY random dash X core. You can look up, I can see that I have a typo here. Random Y core. Those are options that are available. And now, to save time, I'm going to pause the animation for a second, and I'm going to paste the rest of it. You get the idea. Right, so now I have entered in the rest of the code and pushed the check button, and we can see that it says nothing named population has been defined, and so now that's telling us we need to set something up on the interface to define population. And if you look on through, as soon as we clear each of these, you'll find there are several other variables that we need to define that are used in the logic below. All right, next we'll create the interface, and here's a quick look. We have setup, go, population, sniff threshold, sniff angle, and wiggle bias. And we're going to allow the defaults to be fine for the actual animation on the right, the part that you see here. Here you can see that we're going to use the add button to put the setup button, and again to set up the Go code. Very simple. We'll illustrate this live in a second. Then we'll use the slider feature to add the 5 sliders with the information shown here for reference. And once we've added all that, then we should be able to go back to the program, the code tab, and it should now compile without errors. All right, so now we're ready to actually build the interface. So we'll go over to the interface, and we want to add a button. We can just push add and click here, and this is the setup button. So we're just telling it to link this to the setup command over in the code. It's an observer procedure. It doesn't run forever. If we don't put in a display name, it will be the same as setup. That's all there's to it. And interestingly, I would have expected that to match up to setup here. I wonder why. As a test, I am going to copy the word setup from here, Control C, go over to the interface, open up setup, Control V, very puzzling. I'm going to pause the video and figure this out and then tell you what I figured out. It seems to be fine. So I'm going to continue on. The next step is to go ahead and change this to slider and then add sliders. What I'm going to do there, I'll go ahead and type this one. Population. Minimum 0. Increment is 10. Maximum is 400. And current value is 170. And okay. And now we've got past population in our code. We see that it's telling me that I forgot to type a closing bracket. And we can see that that's the case. So to do that, I will just hit carriage return here and put in a closing bracket. That'll help me. Okay, so now that's fixed. And now we're getting some clues about what might be wrong. It says to go, no closing bracket for this open bracket. There may be a bit of a disconnect here. I thought I had pushed the record button and I got quite a ways along and realized it wasn't pushed, and I'm not sure I'm going back to the exact right point, so bear with me. We're on the code and we noticed that I think I might have gotten a little further, but one way to put population is to go Control C to capture the characters. Go to the interface, push add slider, hit Control V, and the maximum population was going to be 400, and the increment was going to be 10 on this one, and the initial value was 170. And as soon as we say OK, then the interface jumps to the next variable that's needed, and I can hit Control C, go back to the interface, add a slider, Control V, and then add the parameters for sniff threshold, which is 0 to 5 and a value of 1.2. So 0 to a maximum of 5, an increment of 0.1, and a value of 1.2. And then do the same with wiggle angle, Control C, interface, add another slider, Control V. So wiggle angle goes from 0 to 45 and is 20, 0 to 45, and has a current value of 20, initial value of 20. And then wiggle bias, Control C, back to the interface, Control V, and in wiggle bias goes from minus 45 to 45. And has an initial value of 0. And finally, sniff angle, Control C, interface, add the last, Control V, and sniff angle goes from 0 to 180 and is currently 50. 0 to 180 and has an initial value of 50. So now we have all of the code in, and we should be able to push setup, and we got an error. So only the observer can ask the set of all patches. It would appear that we've gone on, there's a termination that's not correct somewhere in the logic. So I will go figure that out, and then I will come back and explain what I found and fix it. It appears that the error is, you can see that this ask patches is buried inside of the toSetup. And so that's not going to be allowed. We needed to end, I think when I added this character right here, when I got an earlier error, and I don't remember if this was being recorded or not. I think it was, but perhaps not. I added this character here and I put it in the wrong place. What I needed to do actually was end I just did this wrong. I need to end this with the right square bracket like that, and then I needed to go ahead and ask patches. This will work, but I'm going to move it over because just visually it really helps to read the code that we said CRT and closed that out, and then we asked the patches to set chemical like this, and then we end this whole thing like that. So I'm going to dismiss it. It looks like it's going to compile, and now we can go back the interface and see if we can run setup. Now that looks a little more like what we're expecting, and then we can type go, and we see that very quickly we converge to something like the picture that we saw before. Next, we'll just run some experiments by moving the sliders around and kind of think about why are some parameters more influential than others. And in order to actually do this, you would probably want to go back into the code and look at how it's used and try to tie what you experience when you play with it with what you think when you look at how the code is written. All right, so now we'll just run a couple of experiments as outlined on the preceding slide. First of all, let's just cut this way down to a much smaller number. Go setup and then go. Seems like it's hard to say there's much difference. It happens. We can turn the animation down by slowing it down like this. That might help some. Let's go stop, setup, and go, and watch the aggregation as the molds start to coalesce. And then if we go to the maximum, we get very different appearances, but it's difficult to see exactly what's going on. We'd have to be more methodical in our experimentation. So let's take this back to around the 170 value. What happens? And some of this these we have to run setup and go to do that, but the rest of them we can go ahead and do a setup and then go, and then we can watch, and then we can say what happens if we change the can't change the population, the wrong one. Let's change the sniff angle. Does it have any effect that we can discern? It does seem to change the density of that. Yeah, it's how far away they move. So as we run this up, we see those white areas get larger and smaller. Very interesting. And what about wiggling? Well, how important is that? That has some effect. I'm going to run that sniff threshold back down to the default so we can just focus on the effects of wiggling. Not much effect. What about wiggle bias? Now we start, yeah, that has an effect. They expand outward, and if we run the wiggle bias way down to negative, it has about the same effect, so it doesn't matter which way we run it. So when wiggle bias is 0, things start to condense. And then finally sniff angle, if we run that way up, it seems like things get a little bit more concentrated. And then if we run the sniff angle down, oh wow, that is really interesting. So sniff angle actually has a large effect. And that's all. Yeah, it's just to experiment a little bit here. Next, we'll just use one of the features, just having some fun really. How do you go about changing the shape of the turtles here? They're set to these little diamonds. How would you change the shape so that you could make it look the way you want? And the instructions here, we'll just follow these instructions and demonstrate doing that. All right, so now what we're going to do is go to Tools, the Turtle Shapes Editor, and New, and we get a little drawing palette. So what I'm going to do is just take this orange tool and I guess what I first need to do is select a shape. I'm going to select this shape here and red, And now I'm going to create a red block, and then I'm going to take the this funny looking little shape and make it this other odd color, and I'm going to place it I don't know how to end it. I had to double click. So I make the shape and double click. So now I've made the shape, and that's really all I need to do. I need to give it a name. I'm going to call this WW shape, just for my initials. And say OK. And now we have this shape called WW shape. So now I can exit out of here. And now if I go to my code, I can, where it says set color red, I can say instead, I'll just change it here, set shape WW shape. It says nothing named WW shape has been defined. Well, let's go see if I did something wrong when I created it. Tools, Turtle Shapes Editor. It does appear that WW shape is there, so one has to wonder why that won't work. Let's go back to the thing and just make sure I typed it WW shape with no extra characters. Sure looks like that should work. Oh, you have to put it in quotes. I see now. I'm not following my own instructions. I need to put that in quotes. And now it's happy. So now when I go over to the interface and I go setup, I get my little funny shapes, and they're pretty small, but that's what we have. So just to demonstrate how to create your own animation. And for the final step of this lab, I wanted you to take a look at the primitives list for commands that might be interesting and try them out. And this is the first time we're going to actually use the command center. We can type things in the command center, and so we'll want to formulate something interesting to try out. I probably won't do 3 of them, just in this lab is getting very, very long. But I want to illustrate what happens when you try things out in the command center. Then the challenge would be, once you find an interesting command, could you actually go in and make some change in the slime mold program, actually in the code of your own choosing, to test out the use of a command. That could just be a simple thing like changing colors. It doesn't have to be ambitious at all, but just to kind of step gently into the deeper water from following the bouncing ball and copying what other people have done and actually trying something of your own. No worries if it doesn't work. All right, for this little final thing, what we're going to do is just play a little bit with the command center and just experiment with commands. So one of the first things I thought we could just do is in the observer we could type ask patches. The syntax is brackets, color, blue. I think that's valid. Oh, it wants that to be set color blue. And finally, we learn by mistakes. Set P color blue. How about that one? Finally, now all the patches turn blue. So there's one little tiny test. Of course, as soon as we go again, it's going to set it back. It's going to get overridden. So that's just asking the patches to do something. Another fun thing we might do is just count the number of turtles. So if we just type the word count, turtle, we know that it should return the number that we have in there. They don't die or anything. So it says there's 160. So we can use that command to create. We don't have any monitors in here yet, so let's put a monitor in here and just type count turtles like that and say okay, and it counted them. There's 160. That's how many we created. That's perfect. Now, just for fun, we could ask, this is testing our logic a little bit, ask one of turtles to, we looked at these commands a little bit, die. Ask one turtle to die. Boom! Now we're down to 159. We don't know which one it was. So now we could actually add that line of code in an interesting place. I think we can do it like this. This is a line of code. I can go Control-C. Now that I've worked out the thing that I want, I can now go over to the code and maybe insert that. So at the end of every go procedure, just before it recycles and goes to the next tick of the clock, we could ask one turtle to die and see what happens. Check it. That looks okay. Go back to the interface. Set up. We're back to the normal setup. And go. And look. Wow, that happened pretty fast. Let's dismiss that message. Go back to the interface. We need to slow things down so we can kind of watch that happen. Let's try it about that speed. Setup. Go. It's a little slow. Let me speed it up a little bit. Now we lost one, and so let's speed it up a little bit more. Now they're going away pretty fast, so we can just watch this run. So this is just testing, playing with a little bit of stuff in the run by the observer in the command center, and then putting one of those slightly, a very minor change to the code to have the turtles die off slowly and see how that affects what we see. There's not much going on now with the settings that we have as the turtles die away to nothing. And finally, as we get down to nothing, all the chemical goes away. That's it. End of lab.